Kirchhoff'S rules. Ohm's law is useful only for simple circuits. For more complex circuits, Kirchhoff's rules can be used to find current and voltage. There are two generalized rules. One, Kirchhoff's current rule. Two, Kirchhoff's voltage rule. Physics for everyone welcomes you. Let us learn few important terms. Next, Kirchhoff's first rule, sign convention for first rule, Kirchhoff's second rule, sign convention for second rule. Let us start with important terms. First, let us learn electrical network. Here a circuit diagram is given. Epsilon 1, epsilon 2, epsilon 3 or the EMF, R1, R2, R3 are the resistance of the conductor and the current flowing through R1, R2, R3 are I1, I2 and I3 respectively. A complicated system of electrical conductors is called an electrical network. Next, let us learn junction. Here you have a point C, it's a junction. Next junction is at F. A point where two or more conductors are joined together. Here it is C and F are called the junction. Loop or mesh. Follow the yellow path. A, B, C, D, E, F, A. Good. Next yellow path. A, B, C, F, A. It's a closed path. Next. This is another yellow path, a closed path, C, D, E, F, again C. Any closed electrical conducting path is called a loop or mesh. Any closed electrical conducting path is called a loop or mesh. A branch. C is a junction and F is a junction. A part of electrical network between the junction is called a branch. This is the first branch. C, D, E, F is a next branch. C, B, A, F is a third branch. Any part of the network that lies between the two junctions is called a branch. Kirchhoff's first rule. It's also called current rule or junction rule. Here you have 5 conductors with resistance R1, R2, R3, R4, R5 meeting at a point A. The point A is a junction. The current flowing through them are I1, I2, I3, I4 and I5 flowing through R1, R2, R3 and R4, R5 respectively. Now, this Kirchhoff's first rule can be called as KCR, Kirchhoff's current rule. At any junction, the algebraic sum of the current equals 0, sigma I equals 0. Kirchhoff's first rule. It states that the algebraic sum of currents at any junction of a circuit is 0. It states that the algebraic sum of the currents at any junction of a circuit is 0. Sigma I equals 0. It is a statement of law of conservation of electric charge. The charges that enter a given junction in a circuit must leave the junction, since charge cannot be built up or disappear at a junction. Sign convention. Currents entering the junction is taken as positive. Current leaving the junction is taken as negative. I1 enters the junction, so it is positive. I2 enters the junction, it is positive. I3 leaves the junction, it is negative. I4 leaves the junction, it is negative. I5 leaves the junction, it is negative. So, we can write plus I1 plus I2 minus I3 minus I4 minus I5 equals 0. So, total current entering the junction equals total current leaving the junction is the conclusion. I1 plus I2 equals I3 plus I4 plus I5. Kirchhoff's second rule. An electrical network is given. It's also called voltage rule or loop rule. KVR, Kirchhoff's voltage rule. Around a loop, sigma IR equals sigma epsilon. Kirchhoff's second rule. An electrical network is given. In a closed circuit, the algebraic sum of the products of the current and resistance of each part of the circuit is equal to the total EMF included in the circuit. In a closed circuit, the algebraic sum of the products of the current and resistance of each part of the circuit is equal to the total EMF included in the circuit. Mathematically, sigma IR equals sigma epsilon. This rule follows from the law of conservation of energy. For an isolated system, the energy supplied by the EMF sources is equal to the sum of the energy delivered to all the resistors. Sign convention. 1. The direction clockwise or anti-clockwise can be taken as the direction of traversal. Look at here. Now, here we consider the clockwise direction is the direction of traversal. In the lower loop, once again we take the clockwise direction is the direction of traversal. In all the loop, we have to consider the clockwise direction is the direction of traversal. If the direction of current is in the direction of traversal, then IR is taken as positive. Good. Let us consider a loop here. In this loop, I2, the direction of I2 is in the direction of traversal. So I2R2 is positive. Now look at I3. I3 is also in the direction of traversal. It's in the clockwise direction. Therefore, I3R3 is again positive. In the loop CDEFC, I2R2 is positive and I3R3 is positive. Let us take another loop. In this loop, I1R1, right, is positive because I1 is in the direction of traversal. Now, I2 is in the direction opposite to the direction of traversal. So, I2 is in the anti-clockwise direction. The direction of traversal is in clockwise direction. So, I2R2 is negative. I1R1 is positive and I2R2 is taken as negative. So, we can say that if the direction of current is opposite to the direction of traversal, then IR is negative. If the direction of traversal is from negative to positive terminal of the EMF, then the EMF is taken as positive. Let us consider a loop. In the loop CDEFC, right, the direction of traversal is from negative terminal to the positive terminal of the EMF epsilon 2. So, epsilon 2 is taken as positive. Good. Then the direction of traversal is from negative terminal to the positive terminal of the EMF epsilon 2. So, epsilon 3 is taken as positive. Epsilon 2 is positive. Epsilon 3 is positive. Let us work out the next loop. In the loop ABCFA, the direction of traversal is along the direction of negative terminal to positive terminal of the EMF epsilon. The direction of traversal for the EMF epsilon 1 is from negative terminal to the positive terminal. So, epsilon 1 is positive. Whereas, the direction of traversal is from positive terminal to the negative terminal of epsilon 2. So, epsilon 2 is negative. Epsilon 1 is positive, whereas epsilon 2 is negative. So, for the upper loop, epsilon 2 is positive. For the lower loop, epsilon 2 is negative. Please see this. If the direction of traversal is from positive to the negative terminal of the EMF, then the EMF epsilon is taken as negative. Kirchhoff's voltage rule must be applied only when all the currents in the circuits reaches a steady state condition. The current in various branches are constant. Applying Kirchhoff's rule. Now let us look at the junction C. Applying KCR at junction C, I1 and I2 entering the junction taken as positive, I3 leaving the junction taken as negative. So total current entering the junction C equals total current leaving the junction C. So the equation is I1 plus I2 equals I3. So here is a closed loop. Applying KVR for the loop ABCFA, right? I1 R1 is positive because it is the direction of traversal. I2 R2 is negative because it is in the direction opposite to the direction of traversal. Good. Epsilon 1, the direction of traversal is from negative to positive terminal of the EMF. So it is positive. Then the direction of traversal for epsilon 2 goes from positive to negative terminal. So epsilon 2 is negative. So look at the equation. I1 R1 minus I2 R2 equals epsilon 1 minus epsilon 2. Similarly, let us work out the next loop. CDEFC. Here I2 R2 I2 R2. This I2 R2 is positive because I2 is in the direction of traversal, whereas I3 R3 is again positive because I3 is in the direction of traversal. Look at epsilon 2. The direction of traversal is from negative terminal to the positive terminal of the EMF. So epsilon 2 is positive. Look at epsilon 3. The direction of traversal is from negative to positive terminal of epsilon 2. So epsilon 2 is positive. So look at equation. I2 R2 plus I3 R3 equals epsilon 2 plus epsilon 3. Let us go for the bigger loop. A, B, C, D, E, F, A. Applying KVR for the bigger loop. Now, I1 R1, is it positive or negative? Look at here, I1 R1. It is positive because I1 is in the direction of traversal. Then I3 R3 is in the direction of traversal. So I3 R3 is positive. Epsilon 3. So direction of traversal is from negative terminal to the positive terminal. So epsilon 3 is positive. Then direction of traversal in epsilon 1 is from negative terminal to the positive terminal. So epsilon 1 is positive. I1 R1 plus I3 R3 equals epsilon 1 plus epsilon 3. Thank you, children.